Today's lesson is 6.4, radicals and rational exponents. So the first thing we need to realize is that when we have the square root of x, we could write that as an exponent. So we could actually write that as x to the 1/2 power. Similarly, if we have the cube root of x, we could write that as x to the 1/3 power, and so on. The fourth root of x we could write as x to the 1/4 power. So what happens if we have an exponent underneath the radical? So the exponent underneath the radical would stay in the numerator position. So let's say we have the square root of x cubed. We would write that as x to the 3rd. We could write that as x to the 3rd to the 1/2 power. In other words, we multiply these when we have power to a power, so that could be written as x to the 3/2. Or let's say we have the cube root of x to the 17th. We could write that as x to the 17th to the 1/3 power. In other words, x to the 17/3. If we had the fourth root of x to the 10th, we could rewrite that as x to the 10th to the 1/4 power, or x to the 10/4. Now you can imagine within these you could rewrite these as mixed numbers or simplifying. We should definitely simplify, so this should be written as x to the 5/2 is how we could simplify that down. So the rule that goes along with all of this is, if we have, going in reverse, x to the m over n, remember rational numbers are just fractions, anything that can be written as a over b. So x to the m over n can be written as two different ways we can think about that. We could think about that as the nth root of x to the m power, right? Actually, that's the best way to think about it. So there's your rule, and we'll look at a couple more examples. So for example 1, we'll say 5 to the 3/2. So that's the same as saying, we'll say 25 to the 3/2. There we go. So that's the same thing as saying the square root of 25, square root, right? The denominator is the thing that goes in the index, to the 3rd power. Square root of 25 is 5. And then 5 to the 3rd power is 125. Example 2. We have 8 to the 2/3 power. So I could think about that as, this is the index, right? So the 3rd root of 8 squared. The cube root of 8 is 2. Hopefully we're starting to commit some of these to memory. And we square that. 2 squared is 4. If you forgot that 8 is a perfect cube, you could try it in your calculator, or you could make your factor tree and realize, oh, there is one group of size 3 So that breaks out of jail and becomes a 2 all by itself. Another rule that we'll look at here is when we are multiplying x to the a times x to the b. And we've talked about this before. We're just going to apply it to our rational exponents here. We add the exponent. So that's x to the a plus b. So that's kind of a review. So example 3 here. If I have 81 to the 1/4 power times 81 to the 3/4 power. Before I try and take the 4th root of 81 or cube 81 and then take the 4th root, I'm actually going to start by adding these two exponents. And so I get 81 to the 1/4 plus 3/4 power. Now recall with adding fractions, we add the numerators, the denominators are already the same, so that's 81 to the 4/4 power, simplified to 81 to the 1st power, which is just 81. Example 4. Say we have 9 to the 1/4 power times 9 to the 1/4 power. 9 to the 1/4 plus 1/4 is 9 to the 2/4 power. You simplify that to 9 to the 1/2 power. Now we can rewrite this as a radical, so that's going to be the square root of 9. And we could put this 2 here in the index, but that's our phantom 2, it's not required. Now we can simplify the square root of 9 is 3. So that's how we can work through problems where we need to convert from a radical expression to an exponential expression, or reverse, and how we can multiply numbers with the same base by adding their exponents, their rational exponents. Now on your assignment, do a couple examples. When we have write each expression in radical form, so we could write this as, go back to our notes here, right, this goes back to this rule, so we know this is our index, so that's our radical 5. Again, we could think about that as 2 in the index, and then it's raised to the 5th power. And that's radical form. That's your final answer. And that's all you needed to do for these problems. You don't need to simplify it any further. These say write each expression in exponential form. So we need to consider the base is 6, the exponent numerator is 4, and the denominator is that index value. So 6 to the 4/3 power. And again, that's what you'll do. You're just practicing converting from radical form to exponential form. Now on the back, you do need to simplify. So we're looking to simplify the cube root of 216. So here, this is just like what we did today in class, which is 6.3. So you could take your calculator and see if 216 is a perfect cube. Remember, for my calculator, I have to enter the index first, and then I go to the math key. Number 5 is where I see that index, any index I want, which then 3 becomes that index, and I type in 216, and that works out nicely. So the cube root of 216 is 6. So you do need to simplify each one of these values or expression. And then the last type of problem you'll do is where you do need to add the numerators and then simplify. So when we're multiplying base 8, adding 1/3 and 1/3, we get 8 to the 2/3. Again, don't stop there. We do need to simplify. So this becomes the third root of 8, or the cube root of 8 squared. Again, we did this in the notes, so we know cube root of 8 is 2. We actually did the same problem. Similar. So 2 squared is 4. So you'll practice doing these types of problems through 18, and that's it.